Hello and welcome back to Algebra 1 Honors. Today we're going to be talking about Lesson 6-2, Multiplying Fractions. All right, we're going to start out with some very easy fractions, and I'm going to show you a couple ways that we're going to multiply, and then we're going to gravitate to the way that I feel is probably the easiest way for us to do these. All right, for example, if I had 8/9, okay, 8/9, and I'm going to use a dot here to represent multiplication, times 3/10. Okay, many of us know that you have to multiply the top numbers. 8 times 3 is 24, and 9 times 10 is 90. Now, this is the right answer, but it's always got to be reduced. It's got to be reduced. So in this case, we can say, if we reduce 24 by 6, we get 4. If we reduce 90 by 6, we would get 15. So in this case, 6 goes into 24 4 times. 6 goes into 90 15 times. And this is the correct answer. This is the reduced answer. And this is the answer that everybody will be looking for on all your standardized tests, on your test. Okay, so you always have to remember when you're dealing with fractions, you always want to reduce them down to their simplest forms. Okay, now another way that we've learned how to multiply fractions is what I call by simplifying them first. For example, we're going to use the exact same problem, 8/9 times 3/10. Now I find this method so much easier. And what we do is we can reduce anything from the top and the bottom. This to this, this to this, but you can't reduce anything across. So it's got to be you can reduce any number from the top with any of the numbers on the bottom, or any of the numbers on the bottom with any numbers on the top. So let's look at this. What could I reduce 9 and 3 by? Well, if I reduce it by 3, 3 goes into 3 one time, 3 goes into 3, 9, 3 times. What about 8 and 10? Well, 2 goes into 8 4 times, 2 goes into 10 5 times. Now I've simplified them already, and I'm going to multiply. 4 times 1 is 4, 3 times 5 is 15, and this is our answer, and we don't have to reduce at the end. Our answer comes out already reduced when we simplify before we multiply. Okay, now let's look at a couple more difficult problems, but we're going to do the same exact thing. We're going to do the same exact thing. All right, and this time we're going to reduce before we multiply. Okay? And that's the technique that we're going to be using. Okay, let's look at this one. This one says 6x over y cubed times y squared over 15. Y squared over 15. Okay, well, the first thing that I see that we can do is we can take care of the numerals. We can say what can be reduced into 6 and 15. That would be a 3. So 3 goes into 6 2 times. 3 goes into 15 5 times. Now we can rewrite this, okay, and I'll show you what I mean. Now we can write it x times, and then we're going to have y times y, which is another name for y squared, and then we're going to have y times y times y, which is y cubed, times 5. Okay? So this is the same thing as saying x times y squared over y cubed times 5.
And we need our 2.
And our 2, sorry. Okay, so let's look at this part before we look over here, because this is just a simplified version of this. If I have 3 x's on the bottom and 2 x's on the top, I can cancel this x out, and that's all I can cancel. Is there anything else? I've got an x, no x on the bottom, and a 5. So what this is going to turn out to be is I'm going to have an x on the top.
With a 2.
With a 2, I forgot that 2. And then I'm going to have a 5y on the bottom. Okay, now, here's the way, okay, if you're confused about what exponents mean. Now here's the way I look at it. I say, well, y to the cube means that I have y times y times y. And I have y to the second, 2 y's here. So if I take 2 y's away, this is going to leave me with 1. Okay, can I do anything else? No. So the answer here is going to be 2x over 5y. Okay, and you see that we went ahead and reduced everything. Now over here, without even going over there, I would just say, okay, I'm going to take y squared from here. This is going to turn into a 1, and this is going to just be y to the first power. What do I have left? 2x over 5y. Okay? We simplified before we multiplied. Okay, now let's look at another example. Okay? Okay, let's look at this example. X squared minus x minus 12 over x squared minus 5x, and we're going to multiply it by x squared minus 25 over x plus 3. Okay, the very first thing that we have to do is we have to look at this problem and we have to factor all the polynomials that we can. Okay. Well, in this case, we're going to go ahead and use our regular factoring, and this guy's going to turn out to be this. Okay, he's going to be x minus 4 and x plus 3. Okay. How did I do that? Well, I came over here. You do these enough, you don't have to even use this little handy dandy thing. All right, I'm looking for a negative 1. So negative 4 times 3 gives me a negative 12. Negative 4 plus 3 gives me a negative 1. So my answer should be x minus 4 and x plus 3. And that's what I wrote down. Now the bottom one, okay, well in this case we have to use the greatest common factor, which is going to be x. Take an x out of it, and we're going to have x minus 5. Okay, so we factored the first two. And we're going to multiply. Oh, we should know what that is. Okay, what is that? That's the difference of squares. So in this case, it's going to be x minus 5 times x plus 5. In the bottom, we have just the plain old x plus 3. Now, this is my favorite part. We hunt around and we simplify, we reduce what we can. Well, I've got an x plus 3 on the top and x plus 3 on the bottom. They cancel out, and guess what they make? 1 over 1. They make a 1. Oh, these guys cancel out, x minus 5 and x minus 5. They also equal 1 over 1. Is there anything else we can cancel out? Well, the only thing left down here is an x. So our answer for this problem is going to be this. X minus 4 times x plus 5 over plain old x. Now we brushed on this before, but if we were going to say what variables cannot be used, well, the very first thing, we can't have x equal to 0. Okay, if it was 0, that means that this whole thing will turn out to be unacceptable. It's undefined. So if we were going to get fancy, we'd say x cannot equal 0. What else can x not equal? Well, it can't equal 5, right? X can't equal 5. And the last thing it can't equal is what? It can't equal negative 3. Okay? Those are the restrictions on what this variable for this problem. If there are any of these numbers, then it renders the whole problem undefinable. It's undefinable. Okay? Can't do it. All right? Now let's look at another one. But after this problem, it says now your book is going to give you all a break. It says from now on, we will assume that the domain of the variables do not include values for which any denominator is 0. So this just shows you and it helps you to understand that you can't have any zeros in your denominator. Okay, from now on, we're going to assume that is true, and we're not going to be checking for what numbers the variable cannot be. All right? So let's try another one. In this case, we're going to be using exponents. Okay, and this is knowledge that we learned in another lesson. Okay. And again, what we're going to do is we're going to factor, and then we're going to go ahead and cancel out. So in this case, I have x over 3, okay, and it's going to be cubed. Okay, I guess we're just going to simplify these. And what we do is, this is 1 here and 1 here. Okay, whenever you have an exponent outside of your parentheses, we use what we call the power rule. You take your exponent and you multiply it by whatever exponent is inside the parentheses. In this case, it's 1. So this would turn out to be x to the third power, and down here we would have 3 to the third power, and we'll rewrite it as x cubed over 3 times 3 is 9, 27. Okay? So we're going to have to remember how to do this for this next example. All right, so let's look at our next example. In this case, we're going to be multiplying 2 of these together. Okay, let's look at this one. It says negative c over 2 squared times 4 over 3c. Okay, now, as we talked about before, we can go ahead and put this negative sign here, here, or out in front. Right now it's out in front. So I'm going to go ahead and choose to take that negative sign and put it right in front of the c. Very permissible. So I'm going to rewrite this as this. Negative c over 2 squared times 4 over 3c. Now this is very important because if you have something, a negative c, and it's squared, that's the same thing as saying negative c times negative c, which gives us not a negative number, but a positive number. Okay, many people get confused. They don't understand that the negative sign goes with the c when we go ahead and we square it. So in this case, negative c loses its negative sign and it changes into c squared. So let's rewrite this way. C squared over 2 squared, which is 4, times 4 over 3c. Well, right off the bat, our eyeball should say, well, I can get rid of these 4's. Okay, and they turn into 1's. Now, a c squared is actually c times c. So, just to make it easy for you, we'll write c times c on the top, and the bottom is 3 times c. So, what can we cancel out there? We can cancel out this guy and this guy. So, our answer is going to be c over 3. Okay. Now, the last thing that I want to show you is problem number 28 in section 6-2. Okay, let's see if we can do this problem together. It's very similar to what we just did. Okay, let's just see. Okay, we have this problem. 3z over y to the second power, okay, times 2yz over 15. All right, the first thing we're going to do is we're going to take care of this one. Now, both terms, okay, when we use the power rule, both of these guys are going to have to get it. So what this is going to turn out to be is 3 to the second power, okay, times z to the second power over y to the second power. And I can rewrite that as 3 times 3 is 9 z squared over y squared. Okay, so that was the first one. Now we're going to multiply it by 2yz over 15. Now what we're going to do is we're going to go ahead and reduce. We're going to reduce now before we multiply. All right, let's look at the two numbers, 9 and 15. 3 goes into 9 3 times. 3 goes into 15 5 times. I've got y times y and a y, so I can cancel the y off and just leave one y here. Okay, but the only problem is I don't have any z's on the bottom that I can cancel out, so they have to stay. So I'm going to multiply. 3 times 2 here is 6. Z squared times z is z to the third. And then on the bottom I have 5 times y, or 5y. And this is the answer to number 28. To this number 28 on page, well, I don't know what page it is. All right.